In this video I will show you how to do correct troubleshooting with the Ohmpilot. This video is divided into 3 parts. First of all, we will take a look at the general conditions of a heating element that you want to use. Secondly, we will go through some easy wins, easy measures you can set and that maybe might be already helpful. And last but not least, we will go through structural step-by-step analysis of all the components in order to find the error. Let's start with the heating element. I have such a heating element here, and this has to have certain characteristics so you can use it with the Ohmpilot. First of all, pay attention to the correct power class. If you're using a single phase heating rod, then it must not exceed 3 kilowatt power. If it's a 3-phase heating rod, then maximum 9 kilowatt power. Please make sure the configuration, the cable configuration is the correct one. It needs to have a star and not a delta configuration. If you have any doubts, then please check the manual of the heating element. You will find information there. Thirdly, a neutral conductor connection needs to be available. In some cases, those connections or those connecting points are available, but they are not cabled. Again, if you have any doubts, please check the manual of your heating element. Then please pay attention to the maximum distance or to the maximum wiring distance between Ohmpilot and the heating device. Maximum 5 meters is allowed. And last but not least, it needs to be a dump heating element. So without any control mechanisms or control electronics, because they could disturb the PWM signal that is coming from the Ohmpilot. Secondly, let's go to the easy wins you can do. So measures that can easily be taken and that already might be helpful. First of all, switch on and off the Ohmpilot. In order to do so, switch off the AC fuse, wait 2 minutes and then put the Ohmpilot back on. Secondly, connect to the Ohmpilot interface and remove all settings regarding time and temperature. In order to do so, open the access point and press the touch sensor 2 times. Then connect to the web interface. When clicking on the point General, then you see below here Adapt Day Curve and Maximum Temperature. Remove both ticks and don't forget to click Save. Thirdly, please check the wiring of the Ohmpilot and of the heating element. It sounds very simple, but with the cabling, always mistakes occur. In order to check the Ohmpilot, I open the cover. On the left, you see AC input, and here on the right, this is AC output. This is where sometimes mistakes happen. AC output you see here is from right to left, L1, L2 and L3. In blue you see the neutral conductor connection points. Please note they are bridged internally. So not every phase, not each phase needs to be connected separately. You only need one neutral conductor connection per heating rod. Now we take a look at the cabling of the heating element. This here is an Ascoma heating rod, and here the cabling is done very carefully. You see here L1, L2, L3, the neutral conductor connection and earthing. With other heating rods, it might not be as well indicated as it is here the case. If you have any doubts, then check the manual. As mentioned in the beginning, we need the neutral conductor connection and also make sure that the cabling is done in the right way. We need a star cabling and not a delta cabling. We are now through with the easy wins, and if all that didn't help, then we go to the step-by-step analysis of all components. We will start with the heating element. First we check the temperature sensor of the heating element. In order to do so, we navigate to the temperature maximum first, and then go slowly back to minimum. If the temperature sensor is working, then you should hear a click noise. This click noise means that the bimetal switch is turned off and that the temperature sensor is working. Important for all your further investigation, leave the bimetal switch off, so in the minimum position. Secondly, some heating elements have integrated a security temperature limiter. And this temperature limiter can be activated, for example, when temperature fluctuations happen. In order to deactivate this security limiter, you need to, in this case, we need to press this button here. We press it for a short time and that's it. If the temperature sensor has worked, then we will check the resistance between neutral conductor and phases of the heating rod. We have here 2 kilowatt 3-phase heating rod, and therefore we expect a resistance of around 80 ohm. So I measure here the resistance between neutral conductor and phase 1. We do have around 83 ohm, second phase 81 ohm, third phase 79. If the measured values are a little bit around the expected value, that's totally fine. If it's 2 times or 3 times of what you expect, then this signalizes that the heating rod is to be replaced. If you want to calculate how many ohms to expect, you can do that by yourself. You see our calculation on the screen. I will give you the values for the most common heating rods. So if it is a 1-phase 3 kilowatt heating rod, then you expect 17 to 18 ohm. If it is a 3-phase 6 kilowatt heating rod, then you expect 26 to 27 ohm. And if it is a 3-phase 9 kilowatt heating rod, then you expect again 17 to 18 ohm. We check the heating element and now only 2 sources for the error remain. On the one hand, the Ohmpilot itself, and on the other hand, the cabling between Ohmpilot and heating element. For the next step, we activate the boost mode of the Ohmpilot, and we do this by pressing the touch sensor 3 times. Please note that on this print there's hardly any voltage, and you can also switch on the boost mode and touch this button while the Ohmpilot is switched on. So this is not harmful. 1, 2, 3, and boost mode is activated. If you're activating the boost mode and suddenly the heating element is working and it hasn't worked before, then this could be a signal that the failure is somewhere in the communication between inverter and Ohmpilot. The inverter is giving surplus information to the Ohmpilot, and then the Ohmpilot is activating the heating rod. And if this information is not getting through, then obviously the heating rod is not activated. In order to check the cabling, we check if the 230 volt output of the Ohmpilot also is received at the heating element. So between each phase and the neutral conductor, there should be 230 volt. Before we're measuring that, we are activating the bimetal limiter. So we are going up with the temperature until we hear the click noise. And then I measure voltage between the neutral conductor and the phases. So phase 1 to neutral conductor, there should be 230 volt. The same with L2 and the same with L3. If we have checked everything, so we have the heating element and cabling, and nowhere an error occurred, then most likely just the Ohmpilot remains. One more thing you can do, you can check the output voltage on the Ohmpilot. So between neutral conductor and each phase, there should be 230 volts. If that is not the case, then it is very likely that the Ohmpilot has an error. And finally, I have 2 more hints for you, 2 more shortcuts that can help you finding a mistake quicker. First of all, if you have the material, why not building by yourself a a power socket that you can connect to the Ohmpilot, and then where you can connect a different ohmic load to the Ohmpilot. In our lab, we do have this guy here, and if you connect the power socket to the Ohmpilot, you can connect this floodlight to the power socket, and if this one is running and the heat element is not running, then very likely the heating source has a failure. So in that way you can check very quickly and you see if the Ohmpilot is working or not. And secondly, if you're getting the error message that you have high ohm on one of the phases, then swap phases and see if the error message is moving with you. If you're swapping L1 and L2 and the error message is moving with, then this signalizes that this error is true and actually the heating element is the problem. If the error message is not moving with, then it's likely a failure on the Ohmpilot. In any case, please feel free to contact our tech support at any time. And if you don't need an urgent response, then I highly recommend to use the Solar.SOS app.